This is a short lesson on exponential growth. An exponential function has an expression b to the x where the variable's in the exponent. The base b is a positive number other than 1. An exponential growth function is when anything grows really quickly, and it can be shown that way on a graph. It has the form f of x equals a times b to the x. A is greater than 0 and b is greater than 1. For example, if I have f of x equals 2 times 3 to the x, the 2 represents the initial amount that you start with, and the 3 represents the growth rate. It's how fast it's growing. So in this case, this graph would be tripling over and over and over again. And we can see how quickly that grows by using the Desmos graphing calculator. And if I zoom out, you can see how quickly that graph rises. Application time. We want to write a function that would represent this situation. The population of a city grows at a rate of 5% per year. The population in 1990 was 400,000. What would be the predicted current population? So we start with our initial amount, which would be the 400,000. The growth factor in this is that 5% per year. But since it's growing, we know that we have 100% of our population plus 5 more percent. So we can write that as 105%, or in our function, we'll represent that as 1.05. Remember, with percentages, we move the decimal point back 2 places. Our time is in years. To write my model, we'll start with y equals or f of x equals, either one, they mean the same thing. We start with our initial amount, 400,000, times our growth rate to the x power, and x represents our number of years. So when they ask what would be the predicted current population, we can type that in our calculator. Remember your order of operations, 1.05 to the x, and x in this case would be 24 years from 1990 to 2014. And when we type that in, we get $1,290,039 people. Now, in a perfect world, if things just kept growing like that, that's how many there would be. Now, we also know that in a city that there are people that will be passing away as well, so that may not be quite as accurate, but it is a predicted current population. Let's try one more of those. You deposit $1,500 in a savings account that pays 5% yearly. How much money is in the account after 6 years? Again, we start with our initial amount, which is $1,500. Our growth factor again will be 1.05, and our time again is in years. So to write the function, we start with our initial amount times 1.05 to the t. Now this does say in terms of t. You can use whatever variable you wish. It doesn't really matter. It's a variable. And in this case, if I'm trying to figure out after 6 years how much money would be in there, we can type it in our calculator. Remember your order of operations again. 1.05 to the 6th times 1,500. And after 6 years, you would have $2,010.14. Now that's a short lesson on exponential growth functions. Head on over to the extra examples now to see some other ways that it might be applied in your daily life. Thanks for watching.